All right, let's dive right in. Today, we are taking a deep look at a really critical vulnerability called LDAPNightmare. It sent some serious shockwaves through the cybersecurity world, and you're about to see why it absolutely lives up to its name. So let's start with this number, 9.8 out of 10. That is the near-perfect severity score for LDAPNightmare. You know, in the world of cybersecurity, when you see a score that high, it signals one thing and one thing only, a catastrophic flaw that needs your attention like yesterday. And this quote from the researchers at SafeBreach Labs really tells you what's at stake here. We're talking about the crown jewels of a network, the Active Directory domain controllers. Just think of these as the central brain, the master control panel for a company's entire computer system. If that falls, well, everything falls. So what is this thing exactly? Let's get into the weeds a little bit and break down the vulnerability itself. Its official name is CVE-2024-49112. Okay, so here's the heart of the problem. It's a flaw discovered by researcher Yuki Chen, and it's in LDAP, which is a really fundamental protocol Windows uses for directory information. Now, the key words you need to focus on here are unauthenticated attacker. That means someone with no password, no credentials, no special access whatsoever can, from anywhere on the network, remotely crash or even take control of a server. Now, when Microsoft released the security patch for this, they did something interesting. They didn't include a technical breakdown of how the attack actually worked. And what that did was create this really dangerous information vacuum. It basically kicked off a race against time for both the good guys and the bad guys. And this is where our cyber detectives, the team at SafeBreach Labs, come into the picture. Now, their mission wasn't malicious at all, it was the exact opposite. They needed to reverse engineer this thing, build their own working exploit, so they could truly understand the threat and help everyone else build a much better defense against it. So where do you even begin? I mean, the researchers started with almost nothing to go on. All they had were a few tiny clues from Microsoft's advisory and one really crucial hint from a post on social media. This was digital detective work at its absolute finest. So based on that official report and a really valuable tip from another researcher, Artur Marziano, they started to form a working theory. They suspected it was something called an integer overflow, which is basically just tricking the system with a bad number. They knew it didn't require a password, and that social media tip pointed them to one specific file, WLDP32DLL, as the prime suspect. But right away, they hit their first major roadblock. For this attack to work, the victim server had to initiate contact with the attacker's machine. Now think about that. How on earth do you trick a secure server into doing that? They found a promising function, a way for computers to talk to each other that could ask a server to look up a domain name. But their first attempts just completely failed. And then came the breakthrough. It was such a simple but brilliant idea. See, their first tests were failing because they were using a fake local domain name. The light bulb moment was, what if we use a real public domain that we actually own? So they went out, registered one, and bam, it worked perfectly. The victim's server couldn't find the domain locally, so it did exactly what it was designed to do. It reached out to the public internet's giant phone book, the DNS system, to find the address, and walked right into their trap. Okay, so they had a line of communication open. The next critical step was to build the precise malicious message, the digital poison pill, if you will, that would actually trigger the vulnerability. And here it is, the full attack chain they developed. It's this wild, multi-step dance that starts with that clever RPC request, uses that DNS trick to get the server to talk to them, and ends with the victim server connecting directly to the attacker. But the real magic, the part that actually causes the crash, is in that final step, the malicious reply. This just shows you how delicate these systems can be. The entire exploit, the whole thing, hinges on changing a single byte in the data packet they send back to the server. They change the value that describes the length of a piece of data from its correct value, 1, to an incorrect value, 4. Just a tiny, seemingly insignificant change. And that one tiny change causes a classic error called an integer overflow. This analogy is just perfect. It's like telling the computer to pour a gallon of water into a 1-cup measuring glass. It just can't handle it. The server tries to read memory that isn't there, and that causes a catastrophic failure in the LSSS-exe process, which is basically the security heart of Windows, and the whole system just comes crashing down. And here's the crucial point. This isn't just a problem for those big, important domain controllers. The researchers proved their exploit can crash any unpatched Windows server. The potential impact here is absolutely enormous. So after all of this complex detective work, after understanding this attack inside and out, what's the single most important takeaway? What are you supposed to do now? It really is this simple: patch. Now, the SafeBreach Labs team confirmed it. The security update from Microsoft completely fixes this vulnerability. Their exploit does not work on a patch server. Given how severe this is, patching is absolutely, positively time critical. Of course, we all know patching critical servers isn't always something you can do in 5 minutes. So if you can't apply the patch immediately, your security team needs to be hunting for the digital footprints of this attack, looking for strange DNS queries to outside domains, that specific RPC call we talked about, and any unusual LDAP referral responses. And we'll end on this final, kind of chilling thought. Right now, this exploit only crashes servers, which is obviously bad enough. But the researchers themselves say they are now working on turning this crash into a full remote code execution exploit. They're trying to go from simply knocking the server offline to taking complete control. It's just a stark reminder that in cybersecurity, the race between the attackers and the defenders, well, it never ever ends.